Today our topic is operators in numerical analysis. Lot of operators are used in numerical analysis or computation. Some of the frequently used operators are like forward difference operator, backward difference operator, central difference operator, shift operator, and mean difference operator. We will discuss each and every operator in this lecture. So, operators in numerical analysis. First, we will learn difference operators. Let y equals to fx be a given function, where h is the length of interval and xi are equidistant, means x values are equidistant. Let x equals to x0, then x1, then x2, in this way xn, such that y0 equals to fx0, y1 equals to fx1, y2 equals to fx2, in this way yn equals to fxn, where x1 is what? x0 plus h, because they are equidistant, that is from x0 to x1, x1 to x2 distances are h. They are equidistant. So, x1 equals to x0 plus h. So, what is x2? x2 equals to x1 plus h, and what is x1? x1 is x0 plus h. So, we can write x0 plus 2h. What is x3? It is x2 plus h, that is x0 plus 3h. In this way, what is xn? It is xn minus 1 plus h, that is x0 plus nh. Forward difference operator symbol is delta, defined as del fx equals to fx plus h minus fx. So, the higher order forward differences are defined as del square fx. So, what is the value of del square fx? It is del into del fx. And what is the value of del fx? From the formula we get, it is fx plus h minus fx. So, it is del fx plus h minus del fx. So, what is del fx plus h? From the formula, in place of x, if I write x plus h, we get fx plus 2h minus fx plus h. And minus del fx means it is minus fx plus h plus fx. So, after calculation we get the result fx plus 2h minus 2fx plus h plus fx. So, what is del y0? It is del fx0, and from the formula we already learned that del fx0 means it is fx0 plus h minus fx0, and fx0 plus h means it is fx1. So, it is fx1 minus fx0, that is y1 minus y0. So, we can write del y0 is y1 minus y0. So, we can write del y1 is y2 minus y1, and del y2 is y3 minus y2. So, the higher order forward differences are defined as del square y0, that is del into del y0. What is del y0? It is y1 minus y0. So, it is del y1 minus del y0. And what is del y1? It is y2 minus y1. So, y2 minus y1, and what is del y0? It is y1 minus y0. So, it is minus y1 plus y0. So, after calculation we get y2 minus 2y1 plus y0. Formation of forward difference table. X values are there, corresponding Y values are there. There are 6 sets of X and Y values. So, how many number of columns are there except X and Y? There are 5 columns. So, what is del Y0? It is Y1 minus Y0. So, what is del Y1? It is Y2 minus Y1. In this way, remaining values are this. Now, what is del square Y0? It is del Y1 minus del Y0. In this way, you have to form the total table. So, this is forward difference table. Backward difference operator symbol is nabla, defined as nabla fx equals to fx minus fx minus h. So, the higher order backward differences are defined as nabla square fx equals to nabla into nabla fx, where nabla fx from the formula we get, it is fx minus fx minus h. So, it is nabla fx minus nabla fx minus h. And what is the value of nabla fx? From the formula we get it is fx minus h. And what is the value of nabla fx minus h? In place of x you have to write x minus h. So we get it is minus fx minus h plus fx minus 2h. So after calculation the result is fx minus 2fx minus h plus fx minus 2h. So the higher order backward differences are defined as nabla y1, that is nabla fx1, and from the formula we can get nabla fx1 is fx1 minus fx1 minus h, and what is x1? x1 is x0 plus h. So we can write nabla y1 is fx1 minus fx0, that is nabla y1 is y1 minus y0. In the same way we can write nabla y2 is y2 minus y1 and so on. So what is nabla square by 2? It is nabla into nabla by 2, and nabla by 2 means y2 minus y1. So it is nabla by 2 minus nabla by 1. And what is nabla by 2? It is y2 minus y1. And what is nabla by 1? It is y1 minus y0. So it is minus y1 plus y0. So the result is nabla square y2 equals to y2 minus 2y1 plus y0. Formation of backward difference table. X values and corresponding Y values are given. How many sets of values are there? 5. So, except XY columns, how many columns are there? It should be 4. So, what is nabla Y4? It is Y4 minus Y3. What is nabla Y3? It is Y3 minus Y2. What is nabla Y2? It is Y2 minus Y1. In this way, I have to form total table. Next, what is nabla square Y4? It is nabla Y4 minus nabla Y3. In this way, I have to form this table. So, this is backward difference table. Now, shift operator. Symbol is capital E, defined as EFX equals to Fx plus H. So, the higher order are defined as E square Fx is E into EFX. What is EFX? It is Fx plus H. So, it is E Fx plus H. And what is EFX plus H? In place of x, you have to write x plus h. So, we get it is Fx plus 2h. So, E square Fx means Fx plus 2h. So, E cube Fx means Fx plus 3h. In this way, e to the power n Fx means Fx plus nh. So, the inverse shift operators e to the power minus 1 is defined as e to the power minus 1 Fx is Fx minus h. E to the power minus 2 Fx is Fx minus 2h, and e to the power minus n Fx is Fx minus nh, and e to the power minus half Fx means it is Fx minus half h. So, EY0 means it is EFX0. EFX0 means it is Fx0 plus h, and x0 plus h means it is x1. So, it is Fx1. Fx1 means y1. So, EY0 is y1. So, EY1 is y2. So, e to the power minus 1 y1 is y0. Our next operator is central difference operator. Symbol is delta, defined as delta fx equals to fx plus h by 2 minus fx minus h by 2. And our next operator is averaging operator. Symbol is nu, defined as nu fx equals to half into fx plus h by 2 plus half x minus h by 2. Why it is called averaging operator? Because it is the average of two functions. In our next video, we will learn relation between difference operators. Please follow my next video. For getting more and more updates, please like, share and subscribe my channel. That's all for today. Thank you.